Hello everyone, we're going to continue with section 7.1. In this case is inverse variation. Our learning target today is to understand the inverse variation. Some of the success criteria is I can identify equations and data sets that shows direct variation. Also, I can identify equations and data sets that show inverse variation. I can write inverse variation equations, and I can solve real-life problems using inverse variation functions. So in this case, the Explore It is an activity that you can do in the class. Pretty easy. Just follow the steps and then form your own data information that you can do with a partner, or you can do it with yourself. What we're going to start with is classifying direct and inverse variation. So in this case, we're going to recall that two variables x and y are in proportional relationship when y equals a times x. Remember, in this case, a is a constant, it's a number. 2, 3, 4, 5, 1 half, 2.5, 0.5, whatever number you want here. It's a non-zero number, so it cannot be zero, and it's a constant. When this occurs, x and y are said to show direct variation. When you have a, the constant, times the variable x, then you have a direct variation. Another type of variation is inverse variation, which we are going to study in a moment. So in this case, direct variation is two variables x and y show direct variation when they are related as follows. Y equals a times x, where a has to be different than 0. This is a direct variation. The constant a is the constant of variation, and y is said to vary directly with x. We're going to explain why is that one with example in a moment. Inverse variation is two variables x and y shows inverse variation when they are related as follows. So I have y equals a over x. I can see that my x, my variable x, goes in the denominator. Okay, so in this case, a has to be different than 0. This is inverse variation. Here, x multiplies the variable, that's direct, and the inverse is the x divides the constant. Okay, the x divides the constant, so x goes to the denominator. So in this case, we can say that x times y is equals to a. Okay, and here we can see that y over x is equals to a. So this is direct, this is inverse. So words and math, a variation is a change in the amount or quantity. Direct variation and inverse variation describe relationships where a change in one quantity causes a predictable change in another quantity. So let's do some examples. In this case, example number 1. Tell whether x and y shows direct variation, inverse variation, or neither. So the a, I'm going to write it here. A, I have x times y is equals to 5. Now remember, this is my given equation. Let's solve for y. So y means I'm going to divide by x. So I have that y is equals to 5 over x. So what kind of variation is this one? This one is an inverse variation. Now which one is b? b, I have y equals x minus 4. Okay, solve for y, still the same. So y is equals to x minus 4. This one is neither. Neither. Because remember that the variations are y equals a times x, not plus something minus something, and y equals a over x, not plus something minus something. So b in this case is neither. So let's do the last one. In this case, it's going to be c. So I have y over 2 is equals to x. Solve for y. So I'm going to multiply both sides by 2. So I have y equals to 2 times x. What kind of variation is direct variation. So I have in this case direct variation. In this case, you can give it a try to the self-assessment problems. It's really interesting, the question number 1. So it says, describe the relationship, the equation in example 1b represents. Explain why it does not show direct or inverse variation. So in this case, if we have to describe this one, which is y equals x minus 4, remember that this equation is a linear relationship that is not proportional in this case. What it means is shifted, is vertically shifted. Okay, and if we graph it, it will be vertically shifted. Now, why is not a direct variation? Because there is no proportionality. It's not something like a times x or a over x. It's just x minus something, which is not part of the rules. So you can also say the ratio change, the division. If you divide by x, so for example, if you divide by x, in this case, you're not going to have y over x. Okay, you're not going to have the same. So this minus 4 that we have here is the one that completely changed our relationship. Then the second problems, you can just pause the video, give it a try. Those are pretty straightforward, similar to the examples that we have there. Okay, so let's continue. In this case, we have the general equation y equals a times x for a direct variation can be rewritten as y over x equals to a. So a set of data pairs x comma y shows direct variation when the ratio is division, are constant. The general equation y equals a over x for inverse variation can be written as x times y equals to a. We did that one in the previous example. So a set of data pairs x times y or x comma y shows inverse variation when the product x times y are constant. So I have some data here. Example 2. Tell whether x and y show direct variation, inverse variation, or neither. So the first table I have x and y, 2, 4, 6, 8, negative 12, negative 6, negative 4, negative 3. I do have the table already set up. So I have x times y. So what I'm going to do in this case is multiply 2 times negative 12. So I do x times y. And what I get? Negative 24. Then I do, what is 4 times negative 6? Also negative 24. What is 6 times negative 4? Negative 24. What is 8 times negative 3? Negative 24. As we can see, I have 24 for every single one. So the products are constant. Now let's do the ratio, the division. Y divided by x. So negative 12 divided by 2, in this case, is negative 6. Negative 12 divided by 2 is equals to negative 6. Then I have negative 6 divided by 4 is equals to negative 3 over 2. Negative 4 divided by 6 is equals to, in this case, negative 2 over 3. And last one is I have negative 3 over a. You cannot simplify it. So for this one, I can see that the ratios are not constant. So in this case, I'm going to say, so x and y show inverse variation. Now we're going to find the products and ratios of y over x. So let's start multiplying for this one, b. So we're going to start multiplying x times y. What I have, 1 times 2 is 2. Then I have 2 times 4 is 8. 3 times 8 is 24. And last one, I have 4 times 16 is 64. So in this case, the products are not constant. Now let's do the ratios. So I have y over x. 2 divided by 1 is 2. 4 divided by 2 is 2. Then I have 8 divided by 3 is 8 over 3. And 16 divided by 4 is equals to 4. So the ratios are not constant. So in this case, I'm going to put it here. So x comma x and y shows neither direct nor inverse variation. Perfect. Self-assessment, you can give it a try in the class. So we're going to example number 3. Example number 3. In this case, I have the variables x and y vary inversely and y equals to 4 when x equals to 3. Write an equation that relates x and y. Then find y when x equals to negative 2. Now here, the variables x and y vary inversely. Okay, it's inverse variation. So we're going to use y equals to a over x. We're going to write the general equation for inverse variation. Now I'm going to make the substitution where y is equals to 4 and x is equals to 3. So I have a over 3. Let's solve for a. So I have a over 3, multiply both sides by 3. So I have that 12 is equals to a. So that's the value of a. Okay? That's the value of the numerator. So in this case, what we're going to have is, I'm going to write it here, the inverse variation equation is y equals to 12 over x. That's the inverse variation equation. And in this case, remember when x equals to negative 2, then we have that y is equals to 12 over negative 2 equals to negative 6. Okay, right? An equation that relates x and y, then find y when x equals to negative 2. So I know my inverse variation equation. So now when x is equals to negative 2, is 12 divided by negative 2 equals to negative 6. Let's do the application problem. That was the last success criteria. The time t in hours that takes a group of volunteers to build a playground varies inversely, inverse variation, with the number n of volunteers. It takes a group of 10 volunteers 8 hours to build a playground. Make a table showing the times that it takes to build the playground when the number of volunteers is 50, 20, 25, and 30. Sorry. What happens to the time it takes to build the playground as the number of volunteers increases? Okay, let's start solution. Because it's an inverse variation, I'm going to have that the time t is equals to a over the number of volunteers. Now, I know the time in this case is 8 hours. 8 hours is equals to a over 10 volunteers. Okay, so 10 times a is 80 equals to a. So in this case, let me write here, the inverse variation equation is t equals to 80 over n. So now I'm going to do the table of values. Remember that the n is 15. I have 20, 25, and 30. So what I'm going to do is using this equation. So I have t equals to 80 over 15. Okay, let's simplify. So if you simplify, if you divide 80 divided by 15 is 5 point, I'm going to put it here. So if you do 80 divided by 15 is 5.3333 and so on, right? I'm going to have 5.3 and drop a line there. That means that 3 repeats infinitely. So in this case, I need to convert those ones in hours and minutes. So if I make the division, it's 5 hours, 5.3 hours. So I have 5 hours. Now I need the minutes. So for the minutes, I'm going to take the decimal part, 0.33333, and multiply by 60 minutes. And this one gives me 19.9999 and so on, which is 20. I'm going to have this one is 20. So in this case, I have 5 hours and 20 minutes. Let's do it with 20, in this case, volunteers. So I have 80 divided by 20, which is equals to 4 hours. Let's do it with 25. 80 divided by 25, and following the same as these steps, I get 3 hours and 12 minutes. Now let's do 80 divided by 30. This is equals to 2 hours and 40 minutes. As we can see, the more volunteers we add, the least amount of time we spend on the playground. So it's inversely proportional. So the solution, as the number of volunteers increases, the time it takes to build the playground decreases. Perfect. And that's the solution to the problem. Example number 4, self-assessment. We can give it a try in the class. If you have any question, drop it in the comments, and have a wonderful day.